Picture this: an AI system that can pass the bar exam at the 90th percentile, outperforming 9 out of 10 lawyers, but can't reliably stack 3 physical blocks on top of each other. A machine that writes beautiful poetry about quantum mechanics in the style of Shakespeare, yet hallucinates completely fake legal citations when you need them most. This isn't science fiction. This is the paradoxical reality of artificial intelligence in 2025, and it challenges everything we think we know about intelligence itself. Welcome to Mindcast. I'm Will. Today we're diving deep into one of the most fascinating research papers I've encountered this year, the asymmetry of artificial thought, operationalizing AGI in the era of jagged capabilities. This isn't just another AI hype piece. This is a rigorous analysis that fundamentally reframes how we understand intelligence, both artificial and human. What you're about to discover will change how you think about AI, human cognition, and the strange journey toward artificial general intelligence. We'll explore why AI systems exhibit this bizarre, jagged capability profile, brilliant in some areas, embarrassingly incompetent in others, and what this tells us about the very architecture of mind. By the end of this episode, you'll understand why we're living through perhaps the most dangerous phase of AI development, and why the path to AGI isn't about a sudden spark of consciousness, but about gradually filling up what researchers call the competence matrix. Let's start with some data that will absolutely blow your mind. Harvard Business School, working with Boston Consulting Group, conducted a massive field experiment with 758 consultants, not students, not interns, but actual working professionals. Half got access to GPT-4, half worked without it. The results revealed what researchers now call the jagged technological frontier, and it's unlike anything we've seen before in the history of technology. For tasks within AI's sweet spot, creative ideation, analytical writing, drafting marketing copy, the results were nothing short of revolutionary. Consultants using AI completed 12.2% more tasks, worked 25.1% faster, and, here's the kicker, produced work rated as 40% higher quality than those flying solo. 40%! That's not incremental improvement, that's transformational. But here's where it gets weird and dangerous. For tasks just outside AI's current capabilities, things requiring nuanced fact-checking, rigorous causal logic, or navigating misleading data, performance didn't just drop, it collapsed. Consultants using AI were 19 percentage points less likely to produce correct solutions compared to those working entirely without AI assistance. Think about that for a moment. The exact same tool that made them superhuman at creative tasks made them worse than useless at logical verification. This creates what the researchers call a jagged landscape for users. Now, think about a calculator for a moment. It fails predictably. It'll always give you an error for divide by 0. You know exactly when it can't help you. But AI? AI fails silently and probabilistically. The frontier between what it can and can't do is completely invisible to human intuition. A task that seems impossibly hard to us, like writing a sonnet about quantum mechanics in the style of Shakespeare, is trivial for the machine. But a task that seems embarrassingly easy, like checking whether a specific court case actually exists, can cause the AI to confidently fabricate citations out of thin air. This mismatch between human intuition and AI capability is creating what researchers call adoption risk in our current systems. Now, this jagged landscape becomes even more fascinating when we understand why it exists. And that brings us to one of the most profound insights in cognitive science, Moravec's paradox. Named after roboticist Hans Moravec, this paradox reveals something counterintuitive about intelligence itself. It's comparatively easy to make computers exhibit adult-level performance on intelligence tests or chess, but incredibly difficult to give them the skills of a one-year-old when it comes to perception and movement. Think about this for a moment. For centuries, humans assumed that abstract reasoning, mathematics, chess, logic, was the pinnacle of intelligence because it feels hard to us. It requires conscious effort, years of schooling, intense focus. Meanwhile, walking, seeing faces, grasping objects feels effortless. We do it without thinking. AI has completely inverted this hierarchy, revealing that our subjective sense of difficulty is a terrible guide to computational complexity. Here's the key insight. What humans perceive as difficult tasks are often evolutionarily recent and computationally shallow. Logic, arithmetic, strategy games, these only appeared in the last few thousand years. We have no dedicated neural hardware for them. We simulate them using our general-purpose cortex, which is slow and effortful. Because they follow explicit, formal rules, they're computationally cheap to program. A pocket calculator beats any human at arithmetic. Deep Blue demolished Garry Kasparov at chess. But sensorimotor perception, balance, object manipulation, these are evolutionarily ancient, honed over hundreds of millions of years. They're powered by massive, specialized neural machinery, the cerebellum, the visual cortex, that runs subconsciously and in parallel. Because they rely on implicit, undefined rules of physics and biology, they're computationally incredibly expensive to reverse engineer. We've essentially built the surface of intelligence, language and logic patterns, without the deep evolutionary foundation of sensorimotor grounding. The AI is, quite literally, a brain in a vat that can discuss the philosophy of walking, but cannot take a step. Now, this brings us to the third crucial insight, the architecture gap. To understand why AI systems are brilliant creative generators but terrible logical editors, we need to examine their processing through the lens of what Nobel laureate Daniel Kahneman calls System 1 and System 2 thinking. System 1 is fast, automatic, intuitive, unconscious. It handles recognizing a friend's face, driving on an empty road, completing bread and. System 2 is slow, deliberate, logical, conscious. It handles solving 17 times 24, checking the validity of a complex argument, parking in a tight spot. Two completely different cognitive architectures. Here's the thing. Current AI models, think GPT-4 in its standard mode, function almost entirely as System 1 engines. They generate responses token by token based on immediate probability, without stopping to think. When you ask a question, the model doesn't formulate a plan, verify facts, or critique its logic before responding. It simply generates the most statistically likely response based on patterns it has seen. This System 1 dominance explains those specific failure modes we saw in the Harvard study. Hallucinations? System 1 is an association engine. Ask for a case citation, and it retrieves something that sounds plausible based on statistical patterns. Without System 2 to pause and verify against a database, the fabrication passes through as truth. Long reasoning chains where the model loses the plot? That's because it's predicting locally the next few words, rather than planning globally the arc of the entire argument. It lacks the executive function to maintain long-term coherence. But here's the exciting part. We're starting to see the emergence of System 2 AI, new reasoning models that separate generation from verification. They're designed to pause and search through multiple possibilities before selecting the best path, to use internal critic models or external tools, calculators, code interpreters, to check their work step by step. to break complex goals into subtasks and maintain the state of an overall plan. Think of current AI as a super genius improviser that cannot double-check its work. Adding System 2 capabilities is like giving that genius a scratchpad, a disciplined editor, and the ability to pause before speaking. So, what does all this mean practically? Let me give you 3 crucial takeaways that will change how you think about AI and the road ahead. First, we're living through the most dangerous phase of AI development. We have systems that are generally competent but prone to elementary errors, and we're granting them increasing autonomy. Users are treating Level 1 agents, what researchers call emerging AGI, as Level 3 experts, and that's a recipe for spectacular failures in medicine, law, and critical infrastructure. Second takeaway. The path to AGI isn't about sudden consciousness or a mystical breakthrough. According to DeepMind co-founder Shane Legg, it's about gradually filling up what he calls the competence matrix, moving from emerging general intelligence to competent to expert across thousands of distinct tasks. It's statistical improvement in reliability and depth, not science fiction emergence. The transition from current Level 1 systems to Level 2, performing at the 50th percentile of skilled humans, represents a massive leap in economic utility. Third, understanding jagged capabilities helps us work with AI more effectively. The Harvard study identified 2 successful collaboration strategies. Centaurs clearly divide tasks between human and AI based on understanding the frontier. They know exactly what to delegate and what to keep. Cyborgs integrate their cognition with the machine in real time, providing constant oversight and correction. Both require understanding where that invisible frontier lies. The key is developing what researchers call metacognitive awareness, knowing what you don't know and knowing what the AI doesn't know. Shane Legg maintains his prediction of a 50% chance of achieving AGI by 2028. Whether that specific timeline holds is less important than the trajectory it implies, a convergence of massive scale, multimodality, and System 2 reasoning capabilities. We're moving toward AI that doesn't just generate plausible text, but can think, plan, verify, and adapt. When that convergence happens, Legg argues it won't be a singular scientific event like discovering a new particle. It'll be a societal transformation. The Harvard study shows us a preview. AI acts as a leveler, boosting low performers more than high performers and compressing skill gaps. If expert-level intelligence becomes a cheap commodity, human value will shift entirely to what remains stubbornly biological: virtuoso creativity, physical dexterity, remember Moravec's paradox, and deep interpersonal connection, the very skills that evolution spent millions of years perfecting. But here's what I want you to remember most. We've learned something profound about intelligence itself through building AI. General intelligence isn't a monolithic property. It's a composite of disparate skills that can be decoupled and developed independently. We've built machines with the reasoning capacity of a professor, but the perception of a rock. We've created systems that can write poetry about love, but can't understand why dropping a glass causes it to break. This reveals intelligence as what one researcher beautifully called a bag of tricks, some surprisingly easy to automate, others stubbornly resistant. The jagged nature of current AI capabilities isn't a bug to be fixed, it's a feature that reveals the true architecture of mind. It challenges our anthropocentric assumptions and validates what cognitive scientists have suspected. Intelligence is modular, specialized, and far stranger than we imagined. As we navigate toward 2028, the measure of AGI won't be a single score on a leaderboard. It'll be the gradual filling of the competence matrix, a rising tide of capability that eventually submerges the jagged peaks of human cognitive specialization. Until then, we must navigate this frontier with open eyes, using the System 2 reasoning that we still, for the moment, uniquely possess. The future isn't about humans versus machines. It's about understanding the strange, wonderful, and deeply counterintuitive nature of intelligence itself. We're living through a moment where machines are teaching us what it means to think, to reason, to be conscious, and that might be the most profound gift of this entire technological revolution. Thanks for joining me on Mindcast. I'm Will, and I'll see you next time for another deep dive into the ideas that are reshaping our understanding of mind, intelligence, and what it means to be human in an age of artificial thought. Until then, keep thinking deeply about the world around you, and remember, the most jagged frontier of all might just be the one inside your own mind.